Imagine that Page's license is about to expire. So the city wants to give two licenses instead of one so that there's two bookstores. Now the question is, how much should these licenses cost? In other words, what is the willingness to pay for those licenses? So if there will be two firms, it's very likely that they will not collude and they will behave like a Cournot duopoly. So we're going to remember how does a Cournot duopoly behave. We have the demand as before. That was the total cost when there was one monopoly. Now let's figure out what would be the behavior of two firms. One thing that you must take into consideration is that now each firm is a stranger to each other, and each firm will behave considering the best response of the other firm. This behavior, of course, is more likely, I can imagine, in big cities. In little towns, there can be the case that they collude. So let's start with the case that they don't collude. Now, the whole quantity will be given by the quantity of the firm number one plus the quantity of firm number two, okay? And the price, of course, will be given by 120 minus the quantity of one minus the quantity of two. Now, each firm will have their own cost. The total cost of firm one is given by Q1 square divided by 2, and the marginal cost therefore will be Q1. The average total cost will be given by the total cost divided by Q, which is equal to Q1 divided by 2. Okay? Now, what about the second firm? The second firm has a total cost of Q2 square divided by 2. The marginal cost of the second firm is equal to Q2, and the average total cost of the second firm is equal to Q2 divided by 2. As you can see, all of the equations are exactly the same because they have exactly the same opportunities in this scenario. So if they don't cooperate, what we need to solve the problem for firm 1 first and then for firm 2. The marginal revenue of 1 is given by 120 minus 2Q1 minus Q2. I hope you can recall where this comes from, but if you don't, let us generate the revenue. The revenue is given by price times quantity. Price times quantity in this case is given by 120 minus Q1 minus Q2 multiplied by Q1. And therefore we have 120 Q1 minus Q1 square minus Q2 Q1. And this is the revenue. If we want to get the marginal revenue, then we need to get the derivative, which is equal to 120 minus 2Q1, with respect to Q1, of course, minus Q2. And this is what we're talking about. Okay, so this is the marginal revenue of 1. So having the marginal revenue of 1, we know that the maximizing condition is the marginal revenue equals marginal cost. So that would be equating 120 minus 2 Q1 minus Q2 to Q1, because Q1 is the marginal cost. We just need to solve for Q1. If you say this would be equal to 120 minus Q2 equals Q1, 3. Now we divide both sides by 3. And we get that 120 divided by 3 is 40 minus 1/3 Q2 equals Q1. Or let's put it like this. Q1 is equal to 40 minus 1/3 of Q2. So Q1 is equal to 40 minus 1/3 of Q2. And these that you see here, it's called the best response. It says that for whatever quantity Q2 produces, I'm going to go and divide it by 3 and then add 40. Well, 40 minus that number, sorry. On the other hand, you see that firm 2 has exactly the same shape and faces the same costs. So now we would need to go to the second firm. The second firm, we know it's also maximizing marginal revenue of 2 equal marginal cost of 2, of course. Now, in this case, we have that 120 minus Q1 minus 2Q2 is the marginal revenue. And this marginal revenue must be equal to the marginal cost, which in this case is Q2. And if we solve for Q2 in this case, we have that Q2 it's equal to 40 minus 1/3 Q1. So this one is the best response of Q2, and this one is the best response of Q1. The equilibrium will happen when the best responses cross each other. In other words, when my best response is the best response to your best response. And for that to happen, it must be the case that these two lines touch each other. What we want to get is the quantity and the price at which it doesn't make sense for me to deviate. Okay, so we have the best responses, and now we're going to derive the quantity. So let's start with Q1. 40 minus 1/3. And now instead of Q2, we're going to substitute the value of Q2, which is 40 minus 1/3 of Q1 equals Q1. And as you can see, this equation is in terms of Q1. So if we solve for Q1, we would know what is the optimum quantity for firm 1. So let's do that. It's a little bit of algebra. 40 minus 40/3 plus 1/9 Q1 equals Q1. Now I'm just going to put all the numbers that are constants together. 40 minus 40 divided by 3, 13.333, plus 1/9 of Q1 equals Q1. Now I'm going to pass this Q1 to the other side. In other words, I'm going to subtract 1/9 from both sides, and I'm going to add these two numbers, so I get 26.666 equals 8/9 of Q1. And now I'm going to multiply both sides by 9. So it'll be 26.666 times 9 divided by 8 equals Q1. And if we just plug the calculator, we get that Q1 is equal to 30. So this is the optimum quantity produced by Q1. And similarly, you can imagine that this is also the best quantity, the best response of Q30. The average cost, if you recall, it's very important in order to calculate the profit. The average cost is given by Q divided by 2. I mean, it can be Q1 or Q2. Q1, let's suppose, would be equal to 30 divided by 2 equals 15. So now let us try to calculate the profit. My pencil smaller so that it's easier to draw. Okay, so I'm going to get the price. The price is obtained from the original demand function. So we have P 120 minus Q1 plus Q2. This is 60, and therefore the optimum price is equal to 60. So we have the quantities, we have the price. To get the profit, if you recall, we need to calculate the profit of 1. It's equal to quantity times the price of the good minus the average total cost of each item multiplied by how many items you sold. In this case, it would be 30 times 60 minus 15. So this is equal to 30 times 45. So the profit of firm 1 is equal to $1,350. And of course, the profit of firm 2 is also $1,350. And this is the result of a Cournot strategic behavior without anyone colluding for anything. And if you want to know the total quantity, of course, well, Q1 plus Q2, the price is 60 no matter what. And the profit for the city, let's suppose that the city decides to charge $1,350 per license. In that case, the firm is indifferent between working or not because they have their costs covered and they have zero profit, just like in perfect competition. The major could charge $1,350 for the license, and these people will be willing to participate. Of course, if the major decides to charge less, everybody would be more than happy to participate. And well, the benefit for society, for these people, either the major who gets the money for the licenses or the people who start the business of bookstores in this city, is $2,700.